Hey, what's up guys? My name is Cherno. Welcome back to the Game Engine series, and in fact, welcome to the Game Engine series week. This is a week in which I'm live streaming myself, working on the Game Engine series all day, every day for this entire week, from Monday to Friday, and then every day there'll be at least one episode. I don't think I'm going to commit to two, depending on how much work we get done, but there'll basically be an episode of the Game Engine series coming out every day for this entire week, which is, of course, pretty exciting. Now, last time we were doing, I think, either the camera UI or the sprite render UI. We're basically working on all of the UI for all of the different components inside the Hazelnut editor. I'll have a link up there so that you can check it out. And today we're going to continue on with that and finally be tackling probably one of the hardest things that we need to actually do at the moment, which is the transform component UI. And to do the transform component UI, we're also going to discuss and possibly rework some of the way that transform components work in the first place. So let's go ahead and jump on over into our code and take a look at how everything's going to work. So first of all, I just want to mention that we do have a roadmap. It's hazelengine.com/roadmap. There'll be a link in the description below, and that contains basically the roadmap of what it is we're doing, because obviously it's nice to both have a plan for myself, but also for the community so that you guys have some clarity as to what it is that we're doing. So our current goal, and this is kind of, I guess, what we'll be doing this week as well and working towards this week, because we will finish the UI stuff probably. I mean, I'm going to finish probably writing all the UI stuff today on the live stream, but the following episodes will probably contain the rest of that. Our goal is obviously to get a 2D workflow up and running. Hazelnut UI MVP is what we're working on at the moment. And as you can see, we're up to the transform component UI, and then all of this other stuff I will probably plan and possibly even record later today, and you guys will see it in the coming days. So that's what we're working towards. That's what the previous episodes contained, and now we're up to the transform component UI. So what does that even mean? What does transform component UI mean? So the way that I like to kind of think about this is, I mean, obviously for each of our entities that we have a transform, right? At the moment, we've just got the position, which we can easily modify like this, but we also want to have the rotation and the scale. Now, what I'll do is I'll quickly open up Unity, because it's really important, I think, to actually, when you're developing a game engine, to look at another game engine, just like if you were, developing a game, you would get ideas from another game. If you're working on any kind of research, you always look at prior work and existing work and all of that stuff to see what else is out there and how it's been done. So I basically have this kind of physics test scene in Unity. And if we take a look at, for example, this cube here, what does the transform component look like? What kind of data does it need to hold? Now you can see that I've set a crazy rotation here for one, which is like over 7,000 here. We've got like a position, obviously, X, Y, Z. I like that. I like the fact that, did someone just subscribe? Yeah, thank you, Pseudophone, for subscribing during the video. Nice. It's always good. So as I was saying, we want to have X, Y, Z here so that it's clearly kind of, separated into three different, I guess variables for both the position or for the position rotation and the scale, right? We have rotation in degrees here, and then we have the scale. Now, one thing that I want you guys to pay attention to here is the rotation. The rotation is 7,000. Now, at the moment, the way that we're actually storing our rotation matrix, or rather, sorry, the way that we're actually storing our transform is as a matrix, right? So if we look at our components, and we take a look at the transform component, we just have a GLM mat4. Now, a GLM mat4, and specifically the rotation part of that, cannot store a rotation of 7,000, because obviously if you think about a rotation of 0 degrees is the same as a rotation of 360 degrees, and the same as a rotation of 720 degrees. So the point is that rotations kind of wrap. And because of that, it doesn't really make sense, like mathematically, for us to be storing like a rotation of 7,000, because we could basically mod that number of 7,000 by 360 and it would be equivalent. However, us as humans, when we're developing like these games and maybe for certain gameplay mechanics or whatever, we might want to have a rotation that's like a crazy high number, right? So how can we do that? Well, the answer is we need to actually store position, rotation, and scale separately. We don't want to store them as a matrix. Even though it might make sense for like rendering and other kind of use cases to store it as a matrix, it's really probably not the best thing to do. Now, the answer, or one of the considerations here is, okay, well, how does Unity actually store this, right? Clearly, we know that it can't serialize a matrix, because if it serializes a matrix, then again, it's not going to have a rotation of 7,000. It's going to be whatever that mod 360 potentially is, and probably stored as radians, and we need to decompose the matrix to get all that stuff anyway. So again, Unity stores all of its scene files in like the YAML format, right? So it's just text, because that's the right way to do things when you're making a scene format for a level editor, because obviously if multiple people are working on it, you want to be able to merge that together. If it's binary, you can't do that unless you have your own kind of built-in tools, and that's all obviously a mess. So instead of all that, let me quickly try and find this. So if we grab this physics 2D test as an example, right? This is this physics 2D test that I've created here. We can actually look at the .unity file, which is again just YAML, and we can take a look at how it serializes all this data. So we know that we have, I think that entity is called cube, and it has a bunch of components. I believe this is the transform component. Yes, it is. And then you can see inside the transform component, we have 3 different variables: local rotation, which is a quaternion. We have a local position, and we have a local scale. But then we've also got this local Euler angles hint. And you can see that this is what actually has that rotation of 7,000. So my point is that Unity actually stores these separately. And that's also what we're going to be doing inside Hazel, because, well, we need to. It's not like, if we do store it as a matrix and we continue doing so, that introduces quite a lot of limitations. Not just with this, but with some other stuff in the future as well. And we can obviously avoid that by simply storing them separately. And then every time we actually need the matrix, we can just create the matrix, right? I mean, we're actually doing that already, kind of. If you look at the renderer 2D, then you'll see that we have, like inside our draw rotated quad function, for example, we take in a position size rotation to draw a quad, and then, well, we construct the matrix. Now, obviously, we do have a function here that doesn't do that, and they can already take in a matrix. I imagine we're using that to render with at the moment. But ultimately, you know, we can still kind of render with this or construct the matrix first ourselves outside of the renderer 2D and actually deal with that. So that is what we're going to be doing. Cool. So the first step to doing that is going to be to go into the components and change the way that our transform component works. So instead of having a transform, we're going to remove that. We're going to have a vec3 called translation, which we'll just initialize to 0 by default. You could call this position. I kind of like the term translation. It's just a little bit more formal in 3D graphics, and it might just seem a bit better for applications outside of games potentially. Translation, rotation, and scale. I might change that in the future. We'll see what people think. And scale, of course, I'm going to initialize to being just 1. We're going to get rid of this function. Instead, we're going to take in a we're going to make a constructor that takes in a translation, just because I feel like out of these 3, the one that you would probably want to set most often is the translation. And we'll do that, and then we'll get rid of these operators. I will actually add a function here called glmmat4 get transform const. Now, some people might be annoyed with me doing this here because it's a component. It's just supposed to be data only, and like, oh, the whole entity component system stuff. I don't care too much about things like this, because ultimately speaking, you know, this function existing in this struct or outside of this struct doesn't really matter. Like, computationally, it's just a function, you know? So it doesn't really matter where you place it, in my opinion. It's not like it's going to slow down the performance of this struct or anything, right? It's just a function. It can be outside of this class, doesn't have to be a member function, but then you'd need to take in like the class and call it differently. I just think for convenience, obviously, in the way that you write the code, it's nice to have a function that will take this data and create a mat4 out of it from within the transform component, just because that's a very common use case. So the way that we're going to do this is we're basically going to return glm translate, and I think we'll need to take in a header for that, gtc / I think it's like matrix transform.hpp. So translate glm mat4, and then we'll just take in the translation. Pretty easy. We'll have to multiply that by the rotation. The way that I'm going to construct the rotation here is just using the separate axes. So I'll say glm rotate, glm mat4, angle will be, so for now we'll assume that it's in radians. This is realistically something that you probably want to think about, because almost always we'll probably want to refer to it as degrees. in terms of UI, but obviously when you're scripting, you might be working with like maybe trigonometry functions like sine, cosine, tangent, stuff like that. They obviously want radians. So on one hand, radians is really useful. On one hand, degrees is really useful. I think that maybe we'll store radians here for now at least, and then we'll just convert to degrees and back again for UI. But that way, maybe the script and everything can still, like if we were to obtain this transform component in the script and access rotation, it would already be in radians, so we could easily, pump that into like a sine function or something like that, and we wouldn't need to worry about converting it into radians first. So this is obviously going to be rotation.x 1, 0, 0. Oops. And then we'll rotate on the y-axis. So this is going to be that. And then we're going to rotate on the z-axis. So that's our rotation. Can multiply by rotation, and then we will multiply by the scale. So scale, GLM mat4. And this will just be scale, I think. That's it. Okay, translation, rotation, scale, and we have obviously the x, y, and z rotation. Now, we're not going to really need the x and y rotation for the kind of 2D workflow that we're working with, but obviously it is a transform component, and you should be able to rotate it in the x and y axis regardless. We're not going to have two different transform components for 2D or 3D. Okay, that looks pretty good to me. I think that's pretty much all I wanted to do. Now with these changes, let's try and compile everything, because it's not going to work, and that way we'll be able to see all the errors and easily fix them. So scene.cpp. Okay, so camera transform here, we're actually taking it as a pointer. I guess that's just to avoid the copy. We're going to keep main camera as the pointer, but we'll change this to just be a transform like that. And then we'll simply just do transform.getTransform to get the transform and calculate transform from the transform component. We'll remove this. This transform again is just going to be .getTransform. We could obviously pump in the separate, because there is a draw quad overload that takes in position, rotation, scale like that separately, but we're not going to bother. We'll just still use the matrix. What else did we have here? Scene hierarchy panel was upset. Yeah, so this kind of stuff. So position becomes, we'll get the transform component, which I'll call TC, and then we'll just do TC dot translation. Let's compile everything again. I think there was, okay, here we go. Yeah, so editor layer had some issues inside the camera controller as well. Yeah, so this kind of stuff becomes even easier. So instead of like doing weird, matrix kind of, let's get the last column and access the X, Thanks, Max Scott, for your subscription. Oh, and Pseudophone as well. Thank you guys for your support. I appreciate it. I was going to say that, yeah, with the kind of transform stuff, yeah, instead of like accessing, the last column and the first kind of row of that, which is the X translation, we can just, access the translation using English words, which is obviously a lot easier because not everyone knows that the last column, first kind of field of that has the actual X translation. So now we actually have dot translation, and then if you want to modify X, well, it's just translation.x. So I like the fact that this obviously makes it even easier in terms of API. Obviously, us as potential software engineers, we don't really care. Like, this makes sense to us, makes sense to me at least. But, if you consider other people using this game engine to make games who maybe don't know how a game engine works and how matrices work, obviously this is a lot easier for them, and that's always a win. Unless you're trying to teach them how things work and you're upset because it's too easy. It's too easy to make a game with Hazel. That sucks. All right, so translation X, and then this is obviously translation Y. So everything should still work, obviously, and we'll test it out in a minute. Let's hit F5. I think that should be the rest of the errors. Also, you guys watching will notice that the chat is still on screen. I've made the chat sub only, so if you guys are Twitch subscribers, or you can redeem some Cherno points, which you get by watching the stream. That's what I've done with the chat now, just to make the videos a little bit more exciting for people on YouTube to watch. Okay. So let's maybe put this here. Yeah, so basically no change, right? This still works, which is exactly what you'd expect. I think we can still move around with WASD, and this moves the camera, as you can see here. Everything still works the exact same way. The only difference, of course, is that we're now actually storing translation, rotation, and scale separately. Okay, so that's kind of like phase one of this. It's important for us to move our translation, rotation, scale into being separate. And that's actually going to help us a lot with rotation, because if we try and modify rotation, we can sometimes wind up with gimbal lock and other problems. This should help with that. We'll revisit that in the future when we're doing 3D stuff, because right now it doesn't really apply. Can't really get gimbal lock with a single rotation. But yeah, that should help us out. So the next step's going to be to go into the, let's see. So we want to do the transform UI stuff now. So I was mostly inspired by looking at Unreal Engine, which I can't get up and running on this user account because it thinks it's not installed, because I usually use a different user account for not streaming. Basically, they have different colors, and maybe I can just Google this. Unreal Engine for transform component UI. Someone's done like a little case study. Yeah, here we go. I guess this works. Let's try and zoom in. I forgot Google doesn't like you doing that. Okay, you know what? We're going to be real creative. I mean, I'm sure you guys might be able to see that, but just in case you can't, I'm going to bring up my favorite thing, which is the magnifier, and we're going to look at this. Okay, that is horribly low resolution, but such a fail. Let's try and open this. I'm sure this will be better here. Okay, there we go. Don't need the magnifier after all. So yeah, you can see that basically Unreal Engine has X, Y, and Z. They actually have them color-coded. I really like that design. I think it looks really cool. I prefer that to what Unity has, which we saw before, which is just kind of like that. So I want to make something like this. This was kind of my inspiration. Now, because making like a full-on, you know, UI kind of like this in IMGUI is obviously something that's going to take some time, I decided to do it kind of, instead of trying to work it out in front of you guys during this recording of an episode, I did it during the live stream. And that's why these live streams are pretty cool to catch on twitch.tv/the Cherno. So I basically spent like, I want to say several hours just going through and tweaking everything and making it look nice. And I now have a diff with everything I've done on my monitor here that I'm essentially just going to copy for you guys, and obviously explain the code along the way as well. Because the alternative would be me playing around with little UI code and padding and all of this stuff for like an hour, which I don't think would be fun to watch for anyone outside of a live stream. So let's take a look at what that's going to look like. So first of all, if we go into our, and this is probably going to be a slightly long episode because there's a lot of stuff to do. So basically what we want is translation, rotation, scale, and we want that kind of color coding stuff. And what I've also done in my kind of version is if you actually click on the like X, for example, the red X or the Y or the Z or whatever, it actually resets it back to what it's supposed to be. So for translation and rotation, it resets it to 0. And then for scale, it resets it to 1. So that's pretty cool because it's actually like a button itself, that kind of, the actual kind of red X or the green Y or the blue Z. So let's take a look at how we can do that. So basically at the moment we have a drag float 3. That's fine, but we're actually going to have to split them up because we want to be able to have 3 different controls on the same line for X, Y, and Z, because they have to be different. We can't just have a drag float 3 because we need to have those labels in between. I also want to move the label to the left side. At the moment, you can see that we've got this label on the right side here, position, which was never good. I want to have it on the left side. And by the end of, by the end of today, hopefully, we're going to have a really nice looking transform component, aside from the font, because the font is the default IMGUI font. I actually added the better font on the live stream, but I've taken it away now because we want to do it last. I don't know, maybe I'll lose my patience and do it now, but we'll see. Okay, so how do we do this? Well, first of all, we need 3 of these, right? I guess we'll write the first one here. But ultimately what I think I'll do is I'll just write a function called something like, draw vec3 control, because we're going to be able to reuse this. I'll leave it static for now. We might move it into like a UI library file or something in the future. But basically, we need 3 of these, one for translation, one for rotation, and one for scale. So it makes sense to just have a function and call it 3 times instead. This is going to take in a label as well as the actual vector that we want to modify. I'm also going to take in a reset value. So this will be 0 by default because we, for example, for the translation and rotation, we want to reset them back to 0 when we press the button. But for scale, we want to reset it to 1, not to 0. So that way you can take in a custom reset value. And then I'll also have this parameter here called column width, which you'll see used. But I'll set it to 100 by default because this is basically going to be the width of the labels. So lots of things here, and we probably won't even call that, but it'll just be an option in case we want to reuse this in the future. So basically what we're going to do is IamGUI columns 2, and then we'll have to remember to reset that back to 1. So we're going to have 2 columns, one for the label, and that's how we can get it to look like Unity's does, where it's kind of like, it's aligned essentially to the left, then we have a bunch of space potentially, and then we have this kind of on the other side instead of just basically being straight after the label, because these labels are varying lengths, of course, varying sizes. So we'll have the columns here. I'll set the column width, to 0, and we'll set the width to whatever the column width is. This is going to set our first column to be whatever width this is, kind of like a constant width, so that they're all going to be aligned no matter the label length. And then finally I'll have text, and this will just be the label C-string. And then we'll go IamGUI next column. So this is our first column, and this is going to be the label, as I mentioned. So, and again, I'm literally just copying the diff because working this out live would be a disaster. So next up, we'll push multi-items widths. What this is going to do is basically set up the widths for those 3 controls. So we have we'll have 3 controls and 3 buttons, each modifying the X, Y, and Z value of this vec3 that we're taking in here. So we need to push the widths. And the way that I actually wrote this code, because we can just use, well, 3 because there's going to be 3 of them, and then IamGUI calc item width. The way that I actually did this was during the live stream. I'll give a little bit of insight, although you can of course watch the live stream if you're a patron or a Twitch subscriber if you want the complete picture. But basically, as you saw before, we used drag-float3. So I literally just went into drag-float3 and I looked at the source code for that widget. And I think this was like a drag behavior or something. I don't know how I got to the wrong spot there. Drag behavior T. This may have changed actually since last time, because I did just merge some. Yeah, it's this. I looked at this, and then I think what this does at some point is drag behavior T. Yeah, I think maybe this has been refactored since last time. Let me see if I can find it. Logarithmic stuff. I'm not sure exactly where that was, but basically, let me just see if I can. Yeah, it's been rewritten since I last pulled, I think, or maybe I'm just forgetting where it was. But basically, yeah, here it is. Drag scalar n. That's it, right? So what this is for the number of components in the vector that you're trying to modify. So you might be like a vec2, a vec3, a vec4, or whatever. It's going to basically just have a normal drag scalar, right? Which is what drag float calls here. I don't know how I didn't get there in the first place, but anyway. And then he sets it up by pushing multi-item widths, right? So this is basically what I did. I looked at how the drag float 3 worked, because obviously it had 3 controls laid out side by side, and I adapted some of that code, to have buttons in between and to look a little bit better. And that's kind of what that's where the inspiration came from, and that's also where the actual code came from. So that's how that works. Now, I think to use this though, you need to actually include IamGUI internal. Because it's kind of like internal widget code. Okay, cool. So, and then what I did was, and a lot of this stuff again is stylistic. So I did push style var, right? And then this was like the item spacing. Where are you? Item spacing. I set this to 0 because I wanted it to be really tight. And then I think I had to come up with a button size. So I got the line height. And this is actually coming from the global IM GUI. So this is based on the font. So we basically get the font size. I think you can just get the current font and get the font size, but I wrote it like this. IM GUI style.frame padding .y times 2. Now, funny story, like, well, this came from internally as well when you actually, I think, either use a button or something. This is how it calculates the line height. So this is actually from IMGUI's code as well. I'm not going to go spelunking through that because this episode will be like an hour long if I do, but this, this kind of calculation for line height also comes directly from IMGUI. So this is not like some magic, code. I just looked at how IMGUI does certain things, and now I'm making my own widget. That's essentially what's happening here. So the button size is going to be the line height. So this is the width of the button. It's going to be line height plus 3. So I've just decided to add like 3 pixels of padding because that looks nice. And then line height for the height. And then now we basically need to set up the button. But instead of, and I'll just do the button kind of without the colors first, just so that we see what that looks like. So for example, we have an X button. We'll use button size for the button. And then if it's pressed, we obviously want to reset the values to whatever the reset value is, just like that, right? And then that's done for this button. Now we want to call IMGUI same line because, well, everything's going to be on the same line, obviously. And then we're going to be using IMGUI drag float. Now we don't want a label because we've already provided a label. Actually, the button itself is the label. So we'll just use this hash and then X because we still need to provide it with some kind of ID. If you put a hash out the front, this won't show up as a label. If you just leave X, it'll actually render X as well. You probably can use, you do need a label here. You can't just use like a numeric ID or anything like that. So this is now obviously just going to be values X, and then the kind of speed, I guess, we'll just leave it 0.1 for now. And then we need to do pop item width because we've pushed 3 widths. This is going to pop the first one. And then again, same line. So this, what you see here is essentially all we need. We just need 3 of these, right? So for X, for Y, and for Z. So this is going to be the Y one. And this is going to be the Z one. Z. Okay, I think that is pretty much it. And then at the, I guess we probably don't need a same line at the very end. We can just go back to using columns 1, and I think that's it. So that's the basics of this. Let's go ahead and try and draw this. We'll see what we end up with. So I'll just do draw vec3 control. This is going to be, so the label, we'll call this translation. This is going to be tc.translation. Reset value, we'll leave it 0, column width, we'll leave it default as well. Let's see what on earth this looks like, because I probably butchered some stuff, because I didn't copy everything down because I wanted to make it a little bit more simple as a first pass. Okay, it just crashed. Great. Let's see what we did wrong. Probably just missing like a style modifiers. We didn't pop the item spacing. So I think this style var is supposed to basically, how long is that supposed to be around for? I think until the very end, yeah. So we can just pop it here. There we go. But this is mostly correct, I think. I think the big thing here, yeah. So if we look at this, oh, thank you for the Prime subscription, Poshinator. I think that this, yeah, this looks pretty good, right? So it's a little bit tight, obviously, like if it's that small, but there we go. We have X, Y, and Z here. We should be able to move everything as usual. We just don't have the beautiful colors. And you can also see that it resets. Beautiful, right? And we have translation on the left side with a little kind of column thing here, which we can actually kind of move as well. So pretty cool. Now let's kind of maybe fill in the colors and do the rest, right? And that's really gonna make it look nice. So before we do the button, let's push some style colors for the button. Now, obviously this also took a little bit of time for me to tweak the colors to make them to look right and to look nice, and what I consider nice at least. So if we do push style color, the first color we'll be setting is the button color itself. So there's 3 button colors. There's the normal button, which is just what the button looks like if you're not interacting with it. There's a hovered color for if you put your mouse over the button but you don't click. And then there's an active color for when you're kind of clicked on it. So when you press the mouse button but you haven't let go yet. So for this is obviously the X, so it should be red. I've set it to 0.8, 0.1, and 0.15. And is that, oh, well, we also need the alpha color, right? So then we have button hovered, and we also have button active. So for the hovered, I basically just made it a little bit brighter. So I think I used 0.9, 0.2, and 0.2. And then for the active, I basically just made it the same as the normal button because I didn't want like a billion different colors. So if you press it, it goes back to being the normal color. And then finally, we need to pop these because obviously they have to be different for the other buttons, and you can just do pop style color. Pop style color actually also takes in a parameter here. You can just pop all 3 at once with 1 line of code, which of course is nice. Now button Y and button Z will do the same thing for, obviously with different colors. So let's do them here. You can see why I wanted to make this a function. Lots of code here. And again, we'll probably end up moving this into some kind of UI library in general, because I imagine we'll use this for a lot of different components and probably just outside the scene hierarchy panel in general as well. That's why I've kind of written it as a free floating function. So this is going to be green. Green is, of course, like the brightest color, I guess, or the most lumos. I don't know what the lumos, I don't know. I don't know what the right term is, but green is obviously very visible in the spectrum, which is why you did generally want it a little bit darker. That makes sense as to why these values are slightly darker than they were for red. It's not just like a direct copy, but different hue. So these are obviously, these should be the same. So this should be 0.2. So 0.2, 0.7, 0.2, and then 0.3, 0.8, 0.3. A little bit brighter for the hovered again. And then finally for the blue button, I didn't really want it to look like purple, so I used very little red here, and then 25 for green, and then finally for red itself we have 8. And then obviously these are identical here. And as for this, it just goes up by 1 basically. So 3, 5, and 0.9. Okay, let's take a look at these colors now. They should look very beautiful, I imagine. And they do, right? A little bit squishy here. We can just, should be dragged a little bit more, I think, out. And we probably don't need to 3 decimal places here, especially if we're doing by 0.1. What does Unity do? So Unity has it to, well, I guess it depends on what the number is. So you can see it kind of goes to a small number here, but then if you have it wider, or if you have it like set to something with 3 decimal places, it has that. So we could potentially have that as well. Doesn't really matter. Okay, cool. So that's our translation. Let's do rotation and scale, which of course should be very easy to do. So if we go back to this, rotation and scale. So rotation is rotation, scale. Scale, the only thing that scale needs is the reset value set to 1 instead of 0, because of course we don't want to reset the scale to 0 because we won't see anything if we do that. So now, there you go. Right, we've got translation, rotation, scale. Looks lovely. We've got our beautiful colors here. We can rotate stuff. Oh, right. This brings me to my next point. At the moment, if we try and move one of these, they're all tied, right? Why are they all tied? They're all tied because they have the exact same identifier. They're all known as X, Y, and Z. Now, if you were doing this manually, you could easily fix this by adding more kind of, unique data here. So for example, this might be the translation X, that might be the rotation Y or whatever. But IMGUI also lets you push an ID and pop an ID, which basically means that the next group belongs to a particular namespace, you could say. So IMGUI push ID we can use that for this whole control. And just to keep it simple, I'm just going to take the label, right? So so basically this means that in a particular group, at least, you know, maybe with other IDs that you've pushed, you need to make sure that each vector control has a unique label. If you don't want that, then you can probably refactor this code to do something else. That's it. Push ID, pop ID for that label. Let's hit F5. And now everything should work independently, which is what you would expect. So let's go to the red square and let's try and translate it. Yep, we can translate it. We can translate on the Z-axis, which goes out of the camera clip. Rotation on the X-axis, a bit weird, but we can do that. Rotation on the Z-axis is what we want. Now, hold on a minute. I want this to be in degrees, not radians, because it's a bit annoying if it's in radians, so we'll have to fix that up. And finally, you can see scale works as well, and I can easily reset that back to 1 and reset these just by clicking on them, which is really cool, okay? I really like this control. I think it's nice. So the last thing is, how do we get rotation in degrees? Well, since we've decided that it's up to the client, because the component itself stores it in radians, we basically need to get the rotation and copy it like that, and just chuck a little GLM degrees here to convert it to degrees. We pass in that, and then we could have optionally a boolean that's returned if it changes. That way we don't have to do it all the time, but it's not a big deal, obviously, to convert from radians to degrees. So I'll just do it anyway. We just set TC rotation back to rotation dot, or rather GLM radians rotation, just like that. Okay, and now our rotation should be in degrees for our UI, right? So if I look at the red square and I'll move it a little bit, let's see our rotation. Yeah, you can see that it's now in degrees. If I set it to like 45 or something, then you can see it's obviously at a 45-degree angle. That's it, okay? That is how that works. Now, I wonder if it's easy, because I don't like the fact that I want to make it to 2 decimal places instead of to 3. I think it's a bit noisy. And I didn't do this on my live stream, so let's see if we can work this out live here now. So if I, so obviously the thing that's doing that is the drag float. So I wonder if there is a parameter called format, right? So I'm sure that if we need a min and max, what's the default on that? The default is 0 and 0. So we can leave them as 0 so that we don't have any min and max, because I don't want a min and max. And then format, let's look at the default format, because that will also help us write this. So the default format is just, what I thought it was, same as like for printf or sprintf or whatever. This is the default format. We can just change it to be 0.2f instead of 0.3f. And then, of course, we're going to only have it to 2 decimal places. Let's add these to the rest of the drag floats. Whoops. And now it should look a little bit cleaner. You can have it to 1, or you can have it to, something else. But, oh, I added it twice. Nice one. But I think that 2 decimal places is pretty reasonable. Now, in all seriousness, though, if you want to specify a really specific number, you should probably, maybe it's not good to clamp it to a, maybe you should see what the number is first, and then decide, because obviously if I want to have 0.0001, I can set it to that, but it only appears as 0, which is useless, right? So this might not be something that you necessarily want, but we'll cross that bridge when we get there. Anyway, I think this looks pretty nice. You can see here, and we have the nice labels aligned on this side, and everything else should work as expected. So that is the transform component done now. Let's go ahead and cross that off. It's very satisfying. Next up, in next episode, we'll look at adding and removing entities, right? So we should be able to add a new entity, and then also add new components to that entity. So we can basically start creating scenes and all of that stuff from what we've got. So that is that. Hope you guys enjoyed this video. If you did, please don't forget to hit the like button, or if you're on Twitch, you can subscribe to support the stream or follow. Also, patreon.com/Cherno is the best way to help support this series, and you'll get access to all the past live streams, as well as Hazel Dev, which is like the more advanced 3D C# scripting kind of version of Hazel that has most of this stuff done already. Thank you guys for watching. I will see you next time. Goodbye.